Let's do our third factor affecting enzymes, and we are saying the third, let's do enzyme inhibitors. What about these enzyme inhibitors? On the enzyme inhibitors, we have two types of enzyme inhibitors. One, we are saying the types. We have one, competitive inhibitors. Two, we have non-competitive inhibitors. So in terms of enzymes concentration, you can be given that substrate concentration graph. You can be given that enzyme concentration graph. Then you are told, in case an inhibitor was added, what will happen? Will the reaction go high or decrease? So with the inhibitor, in case you had the original curve, it will have to decrease. There will be decrease in the enzyme concentration. Let's start with the competitive. When you speak about the competitive inhibitor, I love this enzyme. So I'm saying this one is what? Enzyme. This one is active site of enzyme. Then from that point, I love these two to be substrate. This is 1, 2. This second one to be the inhibitor. This one is what? Inhibitor. So what you should understand, the features of a competitive inhibitor, they're of the same shape with the active side. So we are saying the inhibitor is of the same shape with the active side of the enzyme. They're of the same what? Shape with the active side of the enzyme. That is one. Then number two, what again you should understand is, we're speaking about the same shape. You can see the shape is, let's take just an assumption that this is a square, this is a square, this is a square. So what happened? This substrate and the inhibitor are competing for the active side. So we are saying what happens? Second feature is what? Substrate and inhibitor competes. Where are they competing for? For the active side. For active what? Side of the enzyme. They're competing for this active side of the enzyme. Then, when it binds, when this enzyme, when this we're dealing here, it's not about the substrate, we are dealing with the substrate and the other one. So when it binds, this inhibitor, when it binds, so when the inhibitor does what? When inhibitor binds on the active side, what will happen? When this inhibitor binds on the active side, the substrate will not be acted upon. The substrate can no longer be acted. When we speak about cannot no longer be acted, we are speaking about it can no longer be broken down. That is it. So an inhibitor, what's an inhibitor? Let's say the food poisoning, right? You have taken maybe maize which you had aflatoxin. That aflatoxin chemical is what we're speaking about, the inhibitor. And what will happen? That aflatoxin will be having the same shape. If it's a competitive inhibitor, it will be having the same shape with that active side of the enzyme. And we have this substrate. So what will happen? We have that maize and you have the aflatoxin, which is the inhibitor. They are competing for that. It's like a key and lock key model. When you speak about key and lock key model, this is what I mean. Let me use this one. This one is my lock, this is my key. They have to do what? They fit. So they will fit. This one is my active side. This point is my active what? Side. So this is my key. What will happen? You can see they are fitting. And that's what we are saying, they should be of the same shape. When I try to enter this one, you can check like this. This one cannot enter. Why? This is a different key. So this one we'll use to explain on the other section. And this one now we are saying when they bind. Let's say my lock was closed. When it binds, what will happen? This one opens. And because it's opening, because this is a substrate, when the substrate will do this one, it will be acted. But now let's say this one is my inhibitor still, because we are saying of the same shape. What will happen? Once it has binded on this section, the substrate will not have any position to enter. Because when I take another key, it cannot enter because the active side is already occupied. It's already what? Occupied. So what happens? We are saying the substrate can no longer be acted. So how can we do what? How can we stop? How can we eliminate that inhibitor that has binded on the active side of the enzyme? You increase the enzyme concentration. So we remove the inhibitor by increasing enzyme concentration. Hope you understand this is what we are speaking about. You increase the enzyme concentration. When you increase this enzyme concentration, what does it mean? It means you have increased the active sites of the enzyme. So definitely that chemical will be eliminated, which is our inhibitor. Then you should understand again that this form of competition is temporary. This method of what? Of competition causes a temporary change. Causes what? A temporary change. It causes a temporary change. The main reason why I'm saying it's causing a temporary change, because we can remove that inhibitor by increasing the enzyme concentration. It can never alter the shape of the active side of the enzyme. So we are saying cannot what? This inhibitor cannot alter active site of the enzyme. Hope you have learned on this competitive inhibitor. So let me take you to the second inhibitor form, which is the non-competitive inhibitor. We are saying now we deal with what? Non-competitive inhibitor. Non-competitive inhibitor. Non-competitive inhibitor. This is what we are speaking about. Still, this one is our what? Enzyme. This one is our what? Active site of that enzyme. Now, you will check. This one is our substrate. Then, let's say this one is our what? Inhibitor. The first rule that you should understand. The other one we said what? The inhibitor and the active site and even the substrate were of the same shape, so that they can fit. This one, substrate and inhibitor are not necessarily of the same shape. We are saying the inhibitor, you can check this one is a square and this one is a what? Triangle. And you can see this one is a what? Square. So we are saying the inhibitor, substrate, and even that active site, they are not necessarily of the same shape. Then when it comes to this one, we are speaking still about competition, but that one was competitive inhibitor. This one is non-competitive. There is no any competition at all. The main reason, the inhibitor can bind at any part of the enzyme. It has not necessarily has to bind on the active side of the enzyme. So we are saying inhibitor can do what? Inhibitor can bind at any part of the enzyme, not only what? Active side. So this is what I mean. This inhibitor can come and bind on this section, not the active side. This is the binding one. This is the bind what? Inhibitor. And what will happen to this one? It will cause a very permanent change. This causes what? This type of inhibitor causes permanent change. Permanent change means it will have destroyed completely. It will have destroyed what? That enzyme completely. So it means it destroys the enzyme completely. Then again, what you should understand is because it alters the shape of the, because it alters the shape of the active side. It alters what? The shape of that active side. Which one is example of this non-competitive inhibitor? We are speaking here about the heavy metals like lead, mercury, those heavy metals, and that's why it's very dangerous if we consume them. It goes to our brain and it can alter, especially on the child, brain functioning. Then the other thing that you should understand, I think those are just the main. You should know they are not necessarily of the same shape. About the binding, they can bind to the inhibitor, can bind at any part of the enzyme. Then we are saying, so it means because it's causing permanent change, it can never be corrected. The other one we are correcting by increasing enzyme concentration. By increasing what? Enzyme concentration. But we are saying this one, we cannot do what? We can no longer correct. Once it's done, it's just done. Once it has destroyed, it will have destroyed. Hope you have got to understand and learn about these things. So we have said we have these factors which affect what? Enzyme, from temperature, substrate concentration, enzyme inhibitors. And on enzyme inhibitors we have discussed on two. And which are those two? We have said the two are competitive and the non-competitive. The competitive and the what? Non-competitive inhibitors. Non-competitive inhibitors. So from that point now, we will discuss the last one, which is about the temperature. We'll discuss about what? The temperature. But before we do that, let's say the other one, which was enzyme concentration. Let's say this one was for the enzyme concentration. Then you are told this one is what? Enzyme concentration. Then you are told an inhibitor was added. Can you sketch or extrapolate, not extrapolate, but give the hypothesis curve of this one, the hypothesis curve of this one. With an inhibitor, it will be this one. This one, in case we have what? Inhibitor presence. That is it. Thank you very much. As I discussed the last one, which will be on the temperature.